Yeah.
Okay, so you have like three things in a neural network.
Yeah.
You have input layer, hidden layer, and then you have output layer.
Output layer.
Yeah.
Okay.
Okay.
Hmm.
So how a neural network looks is like, we draw it like this. These are neurons.
Okay.
Okay. Now, wait a second. Now all the neurons, they're connected like this.
Okay.
With each, so like we have two layers. Each neuron is connected to every other
Other
neuron
neurons.
of the other layer, of the next
other
layer.
Okay.
Similarly, this layer will have one layer before. It will have, let's say it has three neurons.
Okay.
So every neuron of this will be connected to this,
Okay.
like this.
Okay.
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 Now, for example, in this question, we have like P1 here.
P1, P2, P3.
P3, and this is X1, X2.
Yeah. X1, X2.
Now, the layer which is at the rightmost side, this will be the output layer.
Okay.
The layer which will be on the leftmost side, like they haven't drawn it like this, but it's also a layer.
Okay.
So this is the input layer.
Okay.
Now,
this is input layer and this is output layer.
This is hidden layer.
This is hidden layer.
Yeah. So in every neural network, you will have just one output layer, that is the rightmost. You will have one input layer, which is leftmost, and you can have infinite number of hidden layers.
Okay.
For example, in this case, let's say we have an input X.
Okay.
And this is an output
P.
This is an output P.
Okay.
So in this case, we have three hidden layers, one input.
Yeah.
You can also show it like this, but usually we don't draw this for this for input layer.
Okay.
We just do this and then X.
This is input.
Yeah. So this means it's an input layer. These three are the hidden layers, and this is the output layer.
Okay.
You can have infinite number of hidden layers, but only one input layer, one output layer.
Okay.
Okay, and each layer can have infinite number of neurons.
Okay.
In this case, we have one hidden layer,
Yeah.
and that layer has just one neuron.
Okay.
One output layer, and that output layer has two neurons.
Two output layers, P2 and P3.
No, it's one layer, but
Okay.
two neurons in one layer.
Okay.
If it were like this, let's say like this, then we would have called this would have been the output layer.
Okay.
So layer is always one, but you can have infinite number of neurons in this.
Okay.
It would have been like this as well. Like for example, P2,
Okay.
P3, and then P4. It's a single layer,
Yeah.
but you have three neurons in that layer.
Okay.
So in this case, you have one layer, but two neurons in one layer.
Okay.
This is hidden, output, input.
Okay.
Now, what it has said is, now
This is also hidden or output?
no, this is output. The rightmost is output.
Okay.
So you can see three neurons, P1, P2, P3.
Yeah.
There is no neuron after P2 or
Okay.
P3. This is the last output.
Okay.
There is nothing after it.
Okay.
So this is the output layer.
Okay.
This is in between, so it's the hidden layer. And X1, X2 is the input.
Okay.
Now, in this we have two concepts. One is forward propagation,
Forward propagation.
and then the other is
Backward propagation.
back propagation.
Okay.
Okay. Now,
What is propagation means?
means you have to go. You have to travel in the neuron.
Okay.
In-
You have to go forward travel or backward
Back travel.
Okay.
In forward propagation, you go from input to output.
Okay.
In backward, you
Output
go
to
opposite.
output to input.
You go the opposite.
Okay.
Now, first of all, this is easy thing. We'll understand how to do forward propagation.
Okay.
Now the thing is, let's say this is the neuron, the network. Let me try it again. P1. This is X1.
X2. P2, P3.
Now see, we have like this point is X1, this point is X2,
Yeah.
this point is P1, this point is P2, this point is P3.
Okay.
Now X1 is connected to P1,
Hmm.
X2 is connected to P1, and
P1.
P1 is connected to P2, and P1 is connected to P3.
P3. So
Now-
all connected to everyone.
Now one thing is, each connection has a weight associated to it.
Okay.
For example, this point X1, this point P1. So X1 and P1 are connected.
Yeah.
So this connection, this line will have some weight with it.
Okay.
In this case, the weight is given for P1, X1 is 1.
Okay.
So for this P1 X1,
The weight,
the weight
is
is
1.
1. For P1 X2,
This is still 1.
it's 1. So and P2 P1
P2,
P1 is this line.
Yeah.
This
it's
line's
2.
weight has 2, and for P3 P1
Is
this line has 4. So every connection will have a weight with it. And other thing is, each neuron will have a bias with it.
Okay.
For example, bias for P1 is -1, for P2 is minus.
What is called bias?
Bias, I'll show you in the formula.
Okay.
You just understand that
Yeah.
each connection has a weight.
Yeah.
Each line,
Yeah.
you have 1, 2,
Yeah.
3, 4. 4 lines,
Mhm.
so 4 weights.
Mhm.
You have 3 neurons,
Mhm.
so 3 bias terms.
Okay.
Bias for P1, bias for P2,
Bias for P3.
bias for P3.
Okay.
3 neurons, so 3 bias terms.
Bias terms.
Now, when we do forward propagation, in forward propagation, what we do is we find the output of each neuron. You have 3 neurons, P1, P2, P3.
Yeah.
So we will find the answer of each neuron.
Each neuron. Okay.
Each neuron. First we will do for P1.
Okay.
The answer of P1.
Okay.
And how it's done is, the answer is
Just 1 second. I have plugged in the switch. Yeah.
So now each neuron's output, it's calculated in 2 steps.
Okay.
Okay. First equation is W dot X plus B. This is the
W
first
plus-
equation.
Okay.
W dot X plus B.
Okay.
Dot is dot product.
Okay. Dot
Okay. Now for P1 we have 2 X, X1 and X2. You see how many X are coming to P1. You have this one and the X2.
Mm-hmm.
If there was X3, but let's say X3 doesn't come to P1, maybe let's consider this case. Here is P1,
Mm-hmm.
here is P2, here is P3,
Mm.
here is P4,
Okay.
and here is X1, here is X2, and X3 maybe only till P2,
Mm-hmm.
then P1 till P3, like this.
Okay.
In this case, P1 just has X1 and X2.
Okay.
There is X3 also, but from X3 to P1 we don't have any connection.
No.
So only X1 and X2 for P1.
Okay.
In this case also we have just X1 and X2. So now what we will do is, we have 2X. So each connection will also has a weight with it.
Mm-hmm. 1, 1.
1, 1. So what we do is 1, weight 1 into, that's right, into like this, into
Okay.
X1.
Okay.
The X1 is,
X1 is also.
yeah, they have told us that we have to perform one iteration using the input -1, 3.
-1.3. Okay.
We have X1 and X2. So X1 is -1, X2 is 3.
X2 is 3.
Okay. Now X1 is -1 and the weight for this connection
Mm-hmm.
is 1. So 1 into -1
Okay.
plus. Now for X2 value is 3, and the weight of this connection
1.
is also 1, plus bias for P1. Bias for P1 is -1.
Oh, it will be also given.
Yeah. All the values will be given to you.
So we just have to chit chat this thing.
Yeah.
Okay.
So this will be -1 plus 3
Plus 3 minus 1.
-1. It will be 1.
1.
3 minus 2, 1.
Yeah.
Now this is the first step.
Mm-hmm.
Now the second step is, there is a thing known as activation function.
Activation function.
Now this will be unique for every neuron.
Mm-hmm.
For example, in P1 this is the activation function. For
Okay.
P2 it's t square. For P3 also it's t square.
T square.
Now activation function for P1 is this.
Mm.
So what we will do is, this output, we will put this output in this function.
Mm.
The function is 1/1 plus 3 raised to power minus t.
Okay.
In place of t, we will put 1.
Okay.
So this will become 1/1 plus,
1 plus 3 1. 3 minus 1.
Yeah.
Minus 1 why?
because it's minus t.
Okay. I got
T
it.
is 1, so
Okay.
minus 1. This will become 1 plus 1/1/3.
Yeah.
You will solve this 3 plus 1 4 and 3/4.
4 by 3. Yeah.
Will opposite.
Okay.
So this is the output for final output for P1.
Oh, this will be the final output for P1.
For P1.
That's it.
That's it.
Okay.
First you have to do this.
So P2 will be same, all different.
No, it's same. You have to do it for every neuron.
So let me try a bit.
Now see.
Okay.
In P2, the input is coming from P1.
Okay.
Not from X1, X2. X1 and X2 is connected only to P1.
Yeah. So I have to calculate the weight of P1 to P2.
Yeah. And to P2 only one is coming, P1.
Yeah.
So you have weight for this connection
is 2.
You have output, you multiply plus bias for P2. Bias for P2 is half, you find the value.
Just let me give a try. So P2 it will be like same rule, cell formula.
Yes.
W into X, W dot X plus B.
Plus B.
Plus B. So equals to, I have to calculate the weight first. Weight is 2. P1 to P2 is 2. 2 into X was like given.
No. In this case, X will be the input for P2.
Okay.
Ab P2 mein input you are coming from P1. So the answer of P1 is the input of P2.
Okay.
This is the final answer of P1.
Okay. So
this will become the input for P2.
So the X will be
3/4 for this speed for P2.
3/4. 3/4 plus B will be given.
B is given here.
B equals to half plus half. Then it will be like 2 is 2, like 3/2.
Plus 1/2.
3/2 plus 1/2. It will be like 2. Then like 3 plus 1 4 equals to 2.
Yes.
So that will be the like P2.
And then
first thing.
Now the activation function.
Activation function. So the activation function will be like the rule. Okay.
For P2.
P2 is equal to T square. Only T square.
T square.
So T equals to like 2.
Yeah. Put this value in the function. So T is equal to 2.
2 square.
Yeah. 4.
That's it.
So now this is the final answer for P2.
Okay.
Now you have to do for P3 also.
P3 also.
For P3 also input is P1 only. So the output of P1 goes into P3.
Okay.
Output of P1 is 3/4.
Yeah.
3/4 into 4. The weight is given 4.
So I understood that first thing. Like, but first, like X, where you got the value of X?
It's given in the question. X is minus 1 and 3.
Okay. And where is the Y? I didn't get the Y yet.
First, let's solve this in the net and Y also.
So like, let me solve the P3. P3. So P3 will be like same equation. W into W dot X plus B. So here W equals to weight equals to 4. 4 dot X. Here the X equals to 2.
No. This 2. You have to see
okay,
from where the input is coming.
Okay,
input
from P1.
P1.
So it will be same.
Final answer of P1.
So it's 3/4.
3/4.
3/4 plus B equals to weight. B equals to like 0. So the P3 will be like 4 it's gone. So 3 plus 0 is 3. So I have to calculate the activation function. So the activation function
for P3. Now check what is the activation function.
So activation function will
for
be
P3
equals to T square. T square equals to 3 square equals to 9. So that's it from the first part.
Yeah. This is the answer of first part.
Okay.
Now the
first part is means first question.
Yeah.
Okay. I've got 10.
That's it. But in this we have like this is the first part and second part of the question and.
Okay.
So now we'll do the and.
Okay.
Now see.
So I got 5.
We had like X input. X input was -1 and 3. We also have an output. Y. Y is the output. Okay. It's given to us 3 and 8.
3/8.
So like one output is 3, other is 8. But we have to check what the value we got.
Okay.
Now I told like this is the output layer.
Yeah.
Means this is the final output of our network.
Okay.
P2 is we got answer as 4.
You can use the mouse. Just click it once.
It's on.
Yeah. This one now.
Yeah. See. Now in this thing.
Yeah.
This is our output layer.
Okay.
P2 and P3.
Okay.
So we will write output which we have calculated.
Okay.
Calculated one.
Okay.
This is given.
Okay.
This was the expected output which we expected from our network.
Okay.
But what we got is, we got 4, comma 9.
Okay.
And this 9. This was
4,
our
comma 9 is P2 and P3.
P2 and P3 because that's the output.
Yeah.
Let's say if in case we had another neuron here, like this.
Okay.
So then this would have been output.
Okay.
Check the rightmost layer.
Okay.
Now this is the last thing. Afterwards you don't have any square. You can't see any square.
No.
So P2 and P3 is the final output.
Yeah.
Okay. And what's the final output? 4, 9.
4, 9.
Now this is the thing we have calculated.
Yeah.
But our expectation was 3, 8.
3, 8.
But
okay.
if it's similar, means now see, input is same minus
As
1,
the
3.
output?
No. Like input is same. What affects our output is these weights, weight and bias.
Yeah.
Let's say here weight was, let's say 0. So your answer would have been some different value.
Yeah.
So the answer of network is always controlled by these numbers, weights and the bias terms.
Okay.
If we change these weights and if we change this bias, so our answer will also change.
Okay.
Okay. Now if let's say our given output y was 3, 8 and we got also 3, 8, that means our network is correct. We don't need to change anything.
Okay.
But now it's different.
Yeah.
That means there is some error in these values,
Okay.
the bias and the weights.
So we have to calculate the value
We have
again.
to change them.
Okay.
We have to change this bias and you have to change these weights.
So we have to change by, like, we have to assume the value by
No.
ourselves.
We will this is like we went from input to output.
Yeah.
This entire process, this is known as forward propagation.
Forward propagation. So now we have to go to the backward propagation.
Now we will do back propagation.
Okay.
When we do back propagation, what we do is we change these W's and B's.
Okay. So it's B into X plus W.
No. Wait.
Okay.
Now you understand why we change W and B? Because the value of W and B change their output.
Depends.
Let's say here was 0. So you would have done 2, you would have done 3 by 4 into 0 plus 0. So in that case P3 would have been 0.
Yeah.
And then T square also 0.
Yeah.
So that means these W's and these B's. And let's say here B was 0, let's say here was 9. So you would have got 12, then 12 square 144.
Yeah.
Means I'm trying to say that this W and these B's, they affect our output.
Yeah, they are like the
Deciding factor.
deciding factors. Yeah.
So when we do back propagation, we change the values of W and B. Now we will see that how we change it. Okay. Now there is formula for how to change it.
Okay.
Okay. Now in forward propagation we go from X till output layer. Like we went from here till here.
Okay. Now
In back we'll go from this to this.
Now we'll come from P2 to X2.
P3. P2 and P3
P3
till
to X1 and X2. Okay.
So we'll start from this.
Okay.
Never start from here.
Okay.
Either from X1, X2 when we're going forward, and if we want to go backward, start from P2 and P3.
Okay.
Now for each neuron we had a bias term, like we had bias for P1, bias for P2 and bias for P3.
P3.
Now what we will do is we will write like del C upon del bias for P2.
Okay.
First of all, this means that I am calculating the difference of error with respect to bias of
Okay.
P2 neuron.
P2 neuron.
This is different.
This is P.
This is the figure. So I am doing calculation for P2 neuron.
Okay.
And the bias for P2 neuron.
Is half.
No, this is the derivative.
Okay.
Like we'll calculate this. This was the given, bias was given half. Now we have to change. How we'll change this? We'll change through this.
Okay.
Now this is the formula.
Z. P.
Now this is 1 second. Okay. Now the formula for this is the your calculated value
Okay.
minus the given value
Calculated value minus the given
minus
value.
given value for P2.
Okay.
We are doing the calculation for P2. That's why we wrote here P2. So calculated for P2 minus given value for P2.
Okay.
Multiplied by this term. And this term is given to us this. Now activation function for P2. This is the wrong for P2. Activation function for P2 was given to us as t square. Okay, you know differentiation?
Yeah.
So differentiation of t square will be 2t.
2t, yeah.
Okay.
Yeah.
Now what we have to do is here.
Differentiation is like the power will become in front of the.
Yeah. If it's t cube, 3 will come down.
3t.
And here will be power minus 1.
Yeah.
So 3 minus 1.
Okay.
2.
3t square.
Yeah. If let's say you have t raised to power 4.
Yeah.
Then it will be 4t cube.
3 cube. Yeah.
We had t square. So 2 down. T. 2
this
minus
power
1
is 1.
So 2t.
So it will be t. Okay.
Okay. Now the derivative like calculated minus given into derivative of the activation function of P2. P2's activation function was t square. Its derivation is 2t.
2t.
So into 2t.
Okay.
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 Now this calculated value for P2. P2 like we got the output as for P2 is 4. So 4 minus given is this
3.
is for P2. This is for P3.
Okay.
Because we have two neurons in the output layer.
Okay.
We have P2 and P3.
Yeah.
So this is 3 for this, 8 for this.
Okay.
This is the answer that we want from our network.
Okay.
So 4 minus 3 into twice of now C.
Okay.
T is in this case. Okay. Now for every neuron we did 2 steps. One was this. One was activation function.
Yeah. And in backward?
Yeah, in this also, like in this case we had t square and we put this 2 in t square and we got the output.
Yeah.
Now we have to assume that activation function is 2t and we have to put this value. This value is t. Like whenever you do this thing for a neuron, write this as t.
Okay.
This is t. This is also t. And this is also t.
So only for the first part, not the activation function. Before the activation function, it will be t.
Yes.
Okay.
So now for P2, t was 2. So here we'll put 2.
Okay.
4 minus 3, 1 into 4. 4.
Yeah.
So we have got this term as 4.
Okay.
Now we did this for P2. We'll do this for P3 as well.
Let me try that P3.
Yeah. 1 second. B,
is dp and this is del
C. C
del
is
C.
like error.
Okay.
So del C. In exam you have to write this like this.
Del
Now
C.
try to calculate this for P3.
Okay. It's for P3.
For P3.
So it will be like calculated minus given into 2t.
No, into the derivative of activation function for P3.
Okay.
It can be different as well.
Okay, I got it. Calculated minus given. So calculated minus given and derivative of
the activation function for P3.
Okay.
Now check what is the activation function for P3.
So the
It's t square.
T square is same as 2t. So
Into 2t.
Into 2t. So it is given. So I have to now measure the mark. So P3 we got 9. No. Yeah, P3 we got 9. So the calculation will be 9 minus given. So it was like given was 8. So P3 was given 8. So 9 minus 8, and for P3 the T is 3. So into 2 into 3. 2 into 3. So it will be like 9 minus 8 is also 1. 1 into 6 equals to 6.
So now we have got del C upon del B P3.
P3.
It is 6.
Is 6.
Okay. This we have done.
Okay.
Okay. Now we will do the same for, now see, this was our last layer. Let's say we had 4 neurons.
Okay.
So we will find these 4 terms. Now for every neuron we are done. So go one step back.
Okay.
Now we'll come to P1.
Okay.
In P1, like in this layer, we just have one neuron P1.
Okay.
So we'll find
calculate
this one value for this layer. Del C upon del
P1.
BP1.
P1. Okay.
We did for P2, we did for P3,
and we have to
now
do it for
P1.
So
now for P1, okay. Okay.
I think it's P2 into P1.
See.
Yeah.
Now now see, P1 is connected to P2 and P3.
Okay.
So first we were going like this, now we are going like this.
Yeah.
Assume the arrow is this way.
Yeah.
Initially we were at P2 and P3, now we are going to P1.
Okay.
So on P1, both P2 and P3 are coming.
Okay.
Because it's connected to both P2 and P3.
Okay.
So what we will do is, the bias, this thing which we calculated, this term, 4, like, will be del C upon del B P2. Why 2? Because it's connected to P2. Let's assume we had P2, P3, P4. But if P4 was not connected to P1, so we won't have included here P4.
Okay.
Okay. Into, now see, you have P1, P2. What is the weight for this thing? P1, P2.
2.
2 into 2.
Okay.
Or you can write here weight of P1, P2.
Okay.
Plus the other neuron which is connected to P1 is P3.
P3.
So we will write del C upon del B P3
into
weight for this.
Okay. P1, P2.
For this connection.
P1, P3.
Okay. Let's assume we had this thing. P2, P3,
Yeah.
P4.
Okay.
In this case, we would have done del C upon del BP2 into this P1, P2.
Like
Plus-
there will be one more factor will be added.
Yeah, this thing.
Like just this thing, the same equation. Like it will be like
Yeah,
P1, P4.
plus del C upon del BP4 into this weight P1, P4.
Okay.
But if it's not there, then you won't write this.
Okay.
Only if it's connected, then write this value.
Okay.
Now this you have already you have found this value. It's 4 into weight of this thing.
Okay.
P1, P2 is 2. Plus
Okay.
del C upon del BP3 is 6 into weight of this line. It's 4.
Okay.
So 8 plus 24.
8 plus 24, 32.
32. This is del C upon del BP1.
P1.
It is 32.
Okay.
Okay.
Now the final term. X1, X2.
We have to do this also. Okay.
Okay.
After writing this, wait, let us find it again. Like till here it's correct.
Yeah. The correction is answer is also correct till 32, I think.
Yeah. Afterwards we have to do one more step.
Yeah. Yeah.
This thing.
Mm-hmm.
Let me write it again.
Okay.
Del C upon del BP1 is equal to del C upon del BP2 into weight for P1, P2. P1, P2 plus del C upon del BP3 weight for P1, P3. This term multiplied by similarly we did for last. The activation function for P3, it's derivative.
Yeah.
Here also derivative of activation function of P2.
Okay.
In this case, derivative of activation function of P1.
P1. Okay.
Yes.
Into derivative of okay.
And for P1,
P1
the function is this.
Given.
1 upon 1 plus 3 raised to power minus t.
Okay, we have to derivate this one.
It's given. The derivative of this, we can write it as this. For example, like let's say the activation function for P1, it is given to be 1 upon 1 plus 3 power minus t. Now we have to write its derivative
Yeah.
for P1. it's given, you can write it like the original function, this thing 1 upon 1 plus 3 power minus t multiplied by 1 minus this term, 1 minus, this is given to us, that the derivative of this function is this.
It will be also given.
Usually it's given.
Okay, we don't need to derivate it.
Yeah, because no, like he said that it will be given to you that the derivative of this function is this function.
Okay.
Like derivative is equal to the given function, like sigma p1 into 1 minus this thing.
Okay.
So this thing into 1 minus this thing.
Okay.
This is the derivative of.
This is the derivative of this one.
Yes, derivative of this function is this.
Okay.
This whole term
Okay.
is the derivative of this thing.
Okay.
Now this thing we have already found 32 into derivative of this. Now we have to put t. So t of p1.
Yeah, it's 2, I guess, or 1. It's 1.
This is t for p1. So 1 upon 1 plus 3 power minus 1 multiplied by 1 minus 1 upon 1 plus 3 power minus 1.
Okay.
So 32 into this will be, we have already found this thing here, 3 by 4. So this will be 3 by 4 into 1 minus 3 by 4. So it will be 1 by 4. Okay.
Okay.
So 4 is 32, 4 to the 8, 3 to the 6. Now this is del C upon del B P1 comes out to be 6. We have found
3
for P2,
P2,
for
P1.
P3 and then for P1.
I didn't understand one thing. Like everything was clear, but where it was given? The derivatives?
You may use without proof that the derivative of P1 is given by this thing.
Okay, but how okay, but how did you get 1 plus t? It's like,
see, this thing, this is the simple factorization function.
Okay.
This is 1 upon 1 plus 3 power minus t, and this thing, this dash up on top, this represents the derivative of p1.
Okay.
Now this, see this is given as sigma, like the symbol of p1.
Okay.
Symbol p1.
Okay.
Of t, like t represents this thing.
Okay.
Into 1 minus.
1 minus.
Again that same thing. p1 of t.
Okay.
And this is this.
Okay, we just have to put the value in the equation. Okay.
So this will be this 1 upon 3 power minus t multiplied by 1 is as it is minus again this thing. This thing. And this. Okay. So this is the derivative of this given function.
Okay. So you got P1, P2, P3.
Now this B are the bias terms. Means we have found it for bias. Now we have weights as well. So we'll do this for weights as well.
Okay. Like x1 and x2.
No, again like weights, we have these weights as well. P2, P1, P3, P1. So like first we went from here till here and we found the derivative, like del C, for all the bias terms.
So it's like new weight values. Like there are like 6. Like we got the new 3 values.
We will, from these values, we will calculate the bias term.
Okay.
Like wait.
Just 1 second. I need to put this separate from this. Okay. Yeah. Like everything is clear. Just one thing. Just I didn't got the one thing. Like we got the new 3 values for P3.
These are not the new values. Actually, what we do is we write it as the original value. Let's say B for P1 is equal. Sorry, the new value. The new value which we want to find is the original value minus something multiplied by this derivative which we have found. 6. So this is the way with which we find the new value.
Okay. So we have to, like, now we're gonna find the new value.
Yes, we have found this thing.
Okay.
This is already given, the original value, and this will also be given to a question.
Okay.
This thing, this
Okay.
some term here.
Okay.
We only had to find this value,
Okay.
which we have found already.
Okay.
So after we find all the values, then we will together find all the new values for
Okay.
weights and bias.
Okay.
Okay. Now we went from here till here, and we found the
New bias values.
bias values. Now we will do the same for weights as well.
Okay.
We will again start from back,
Okay.
from P2 P3.
Okay.
So means del C, this term remains same, upon instead of BP2 we will do weight P2, and this weight from P2 it is connected to P1. So P2 P1.
P2 P1. Okay. Okay.
Because weight
yeah,
is
got it.
all
Will be the. I understand it.
into is equal to. Now the formula for this is. Okay. Now the formula for this is.
Yeah.
First you have P2 because you go from back to front.
Now I'm
So
going.
first P2, then P1.
Okay.
This will be the bias for P2 because first you have P2. We have already found this value multiplied by.
They'll say bias of P1.
No. In this case, no bias.
Okay.
In this will be C. For every neuron, we had T.
Yeah.
And one answer which we get after putting T. So let's call this as Z.
Okay.
So into Z of P1.
Z of P1 is
P1.
the activation.
Final output after activation function.
Okay, like this one. Like for this is one. No, this one.
Yeah, it's here.
Yeah. Is
3 by
the
4.
like activation function.
Yeah, after
3 by
activation
4.
function 3 by
Okay.
4. So this we've already found. Del C upon del BP2. This one is
This one is there.
4. BP2 is 4. 4 into
2
final output of P1.
2 into 3 by 4.
No, it's Z.
Oh, okay. Sorry.
So answer is 3.
3.
That's it.
Okay.
So this is P2 P1. The
Okay.
weight
Okay.
3. Weights are very simple.
Okay.
Now del C upon del W. Now
P3
P3
P1.
Again, first we have P3.
Yeah.
So bias of P3 into final output of P1 after the activation function.
Okay.
This we have already found out. 6 into 3 by 4.
3 by 4.
2 2 is 4. 2 3 is 6. This is 9 upon 2. 4.5.
Okay.
So this is del W P2 P1
P2 P1
is 4.5.
P3 P1.
Oh sorry, P3
P1
4.5. Now this is done. This is done.
Okay.
Now we are at P1. Now in bias case, we didn't have any bias for this.
Okay.
We only had bias for P1, P2, P3. But weights, we have weights for this. We have weight for this. We also have weights for this line and for this line. So first we found these values for these lines. This P2 P1, P3 P1.
Yeah.
We did this. Now we'll find the values for P1 X1, P1 X2.
Okay.
Because we also have these weights.
Yeah.
So del C
So
upon
we have
del
to find another velocity of x1
W P1 X1.
P1 x1.
From P1 till X1.
Okay.
We in back this whole propagation.
Yeah.
We look from this side. So P1 then X1. P2
Okay.
then P1.
Yeah, I got it.
Okay.
So
P1 X1 again same thing. Del C upon del. Now in
Del.
this case we'll have bias for P1
P1
into. Now see, in previous case what we did was we multiplied with the final value of P1. But in this case we have X1. So the given input. What was the input for X1? -1
-1.
into -1. That's it. This we have found here.
Like, how did you get the -1?
It's given the input.
Okay.
You have -1, 3.
Okay.
So this will be X1.
Okay.
This will be X2
Okay.
automatically.
Okay.
Into -1 into X1 into X1.
Okay.
This we have found as 6. So 6 into -1.
minus 6.
Minus 6.
This is
is
the
done.
x1.
This is del C upon del
P1
x1.
P1 x1.
Now P1 x2.
Yeah.
P1 x2. Again we have P1.
Same thing. Yeah.
So del C upon del BP1
Del B
into
P1
x2 because we have x2 here.
Yeah.
This is 6 into x2 minus 1 and 3. So x1 is minus 1, x2 is 3.
Okay.
X2 is 3. 18. That's it.
Okay. Now
So-
we got minus 6 and 18 new two values.
Now we will find new values from this.
Okay.
Now how to find new values?
So now we'll go again for
No.
Okay.
We'll update the weights
Okay.
and bias. How to update? See, first we'll write all the values here. Like B bias for P1 was minus 1.
Yeah.
Bias for P2 was half.
Half.
Let's write it at 0.5.
And 3
Bias
is
for
0.
P3 was 0.
0.
Now the weight for x1 P1 was 1. For x2 P1 was also 1. Now P1 P2 was 2
Okay.
and P1 P3 was 4.
Okay.
X1 P1, X2 P1,
Okay.
P1 P2,
Yeah.
P1 P3.
Okay.
Okay.
Yeah.
Now these all values
Are given.
were given. Now we have to find the new values.
Okay.
For new values we'll do minus. Now this is the like some value multiplied by which we have calculated these things all.
Mm-hmm.
Now this thing is given to us as 0.1.
Okay.
This is the step size.
Okay.
So the new value is original value minus step size, which is 0.1. 0.1 into all the values which we have calculated, these all.
Okay.
Now we are doing for bias of P1.
Hmm. Bias of P1.
It's
Is
6.
it 6?
No,
Yes, it's 6.
no. Yeah, it's 6 here.
This is the bias of P1.
Yeah, see. Del C
Okay.
upon del BP1 is
Okay.
6.
6.
So into 6. So means minus 1 minus 6 upon 10.
Hmm.
Minus 16 upon 10. So minus 1.6.
1.6.
This is the new bias for P1.
Okay.
For P2, original value minus, it's minus only na, 1 second. It's minus.
Okay.
So minus 0.1, which is given into the term for which denominator is BP2.
Okay. GP2 is
Yeah, 4.
4.
This term
Yeah.
into 4. So 0.5 minus 4 upon 10 or 0.4
Okay.
will be 0.1. So this is the new value for bias.
Okay. It is 1.6 minus 1.6. It is 0.1.
Similarly, you have to do for all this.
All the
We
things.
Yes. We have.
Okay. Let me try one.
Mhm.
Like for this one, PP3,
Hmm.
it's like 0 minus 0.1 will be
It's
fixed.
same for all.
0.1 into like there's bias for 3 P3. So bias for P3 is like P3 is 6. So into 6 it will be like 0. So minus 0.6. 0.6 minus.
This is the answer
Okay. And like we have to
for
do
weights as well. Same formula.
So weight is like weight is given or like the new one.
This is the original value
Okay.
minus
P1.
this thing
Okay, this one minus 0.1
into the it's x1 p1.
x1
P1 is this. Like x1 p1 or p1 x1 is same.
P1 x1 and x1 P1 same. So it's like minus 6.
Minus 6.
Into minus 6 equals to 1 minus plus 6. So 1 plus
0.6. 1.6.
yeah. It's 1.6. Then it's like 1 minus 0.1 into P1 x2. P1 x2. So P1 x2 is 18. So into 18. It will be like
1 minus 1.8.
1 minus 1.8. So it will be like minus 0.8.
Minus 0.8.
Minus 0.8. Then is WP1 P2. So it's 2 minus 0.1 into
for P1, P1 or P1 P2.
P1 P2 like is this one?
Yeah.
4.5.
No, it's 3.
Oh, sorry, yeah, it's 3 into 3. So it will be like 2 minus
0.3.
1.7. And this will be like 4 minus 0.1 into P1 P3. P1 P3.
It's here.
Oh, P1 P3 4.5 into 4.5. It will be like 4 minus 4.5 equals to minus 0.5.
No, it will be 4 minus 0.45. So it will be 3.
Okay. 3.5.
3.65. 3.35, sorry. No, sorry, 3.45.
3.45. 3.45
3.45
or 3.55? I think it's 3.55.
Sorry, yeah. 3.5.
3.55.
Yeah.
3.55.
So this is the final answer.
Okay. This is the final answer.
Because we had to change the weights. Now, if you do calculation instead of using the, like what we did was w dot x plus b, the activation function. Now, instead of taking these values 1, 1, 2, 4, minus 1 half, 0, if you take these values, the answer will be 3, 8. That means we are done. You don't need to show it, but it's like theoretical. Like if you will use these values instead of these values, the answer will be this 3 and 8. Like this. So this is the entire question of the building blocks.
That's all.
If you practice this like 2 times, you'll do all this in, let's say, less than 10 minutes.
Okay, like I have to do the chit chat things. I have to do the formula like first
Only
to last.
formula. Yes, that's it.
Yeah, and
from forward to backward, like from front till last, then from last till front.
Okay.
You have the formulas.
Yeah.
You only have to put the values in the formulas.
Okay.
The difficult part is to remember formula, but you can always, like in exam also, we will write the formulas on sheet, so it's not an issue.
Okay.
You write a general formula on the cheat sheet, look at the formula, put the values, and you have to do the calculation.
Okay, I got it. I have to just take the chit chat and that's it. That's all.
Yeah.
And like, what is this? Okay, I'm not gonna give you much more pain. We're gonna solve next time in the. Like...
No, it's 2 minutes question.
Okay.
Yeah. Now he's saying, okay, he's saying that see, we found the like we found all these values. This. We found all these values. Now he's saying that I'm already giving you these values.
Yeah.
So these values which we did here, like original minus 0.1 into the values which we found. He's saying I'm already giving you those values. You don't need to find them. Put these values here and then again find the answer. That's it.
So how can I understand that which value is which one?
For this, it's written here. See. First value is P1x1.
Okay.
This one.
P1x1.
P1x2. This
P1x2 is a gap. It is the weight of P1x1, P2, P1x2.
P2,
okay,
P1,
we got it.
P3, P1.
Okay,
Yes.
And we have to do the forward function again.
No, not the power propagation. This thing. You have the original value. These are not the final values.
Okay.
You have to find the final values. He's saying you don't need to do all this. I'm already giving you this. I'm already giving you these values.
Okay.
You have to take the original values minus 0.1 into these values.
Oh, just this.
Yeah. Like what
got
was
it.
like, let's say for BP1,
Hmm.
the new BP1,
Okay.
we had original BP1 minus 0.1 into del
The
C
new
upon
values.
del BP1, which we calculated. This thing. He's saying, I'm already giving you this del C upon del BP1. You don't need to find this. This is given as like from here, third
BP1,
term.
yeah.
So
From last
here,
third.
Yeah, from last third.
You can use the mouse. It's easy.
1, 2,
10.
3, 10. So you don't need to find this. Just put here 10.
Okay, just I have to find the new values only.
New values. In first question, what we did was we had to find these values. This.
Yeah.
He's saying you don't need to calculate those. I'm already giving you these. This is given in the question.
Yeah.
This 0.1 is also given.
Yeah.
He's saying you don't need to do all this. I'm already giving you these values.
Okay.
So just put here and find these values. Find the values.
Okay. Like if someone didn't do the first part, if they want to do the second part, they will get 2 marks for free.
Not 2 marks, one more.
Yeah, 2.
How
It
much
was 2.
it's?
It was 2.
2 marks.
So 10 plus 2, 12.
Yeah.
Oh.
And sometimes they can also say that you found these values, like
Yeah.
after calculation, you add, like what you do is
You should have some water. And I have some juices like orange juice, like no orange, it's like watermelon. So you like watermelon?
No, it's
And
very
like,
late now. I won't have any juice.
it's like 2 minutes.
No. Like at night, I usually avoid juices because they
Why?
have sugar in it.
But there are some like what is you call like the red ones, the
Pomegranate.
Yeah.
No, but they still have sugar.
Okay.
I don't like sweet,
Okay,
like cold
fine.
drinks and all. I don't like much.
Okay.
Yeah. So like we have these values. Now he's saying like we found these values all. He's saying these are also the values. So add both and then do this thing.
Okay. So
Like-
what is the T in the like top of T?
Transpose. Ignore
Okay.
that.
Okay.
It's not important. So now like he's saying now what are the updated weights and bias if we use both the points? Means for first point minus 1 and 3 we found these values on del C, P1, P2, P1, P1, P3. Now he's saying those values plus these values, you add them, divide by 2, you take the average basically.
Okay.
So average is
like first value, this value, and the didn't
let
understand.
me again tell you. When we found all these values,
Yeah.
what we will do is we will write it as this is the things which we calculated. So theta is equal to first P1 x1 this minus x, then it's P1 x2 18,
Yeah.
then P2 P1
P2 P1
3,
3
then it's done P3 no it's
P3 P1 P3 P1
I think it's, yeah,
P3 P1
4.5.
4.5
BP1 is 6,
6
then BP2 4, and then BP3 6. This is theta. He's saying these are the values which we have calculated. Okay, and he's saying use these also and these also. So we'll write like 6 2 1
5 5.5
5
10 minus 4 2
minus 4 2. We will add these both, divide by 2 because these are two things.
Okay.
So find the average.
Okay, we have to make the like one value.
Yeah. So add 0 upon 2. This is 20 upon 2. 4 upon 2, 11 upon 2,
10
sorry,
upon
10 upon 2, 16 upon 2, 0 upon 2, 8 upon 2.
Okay.
We have made this one value. Now use this value for finding these. That's it.
So okay, we have to do twice these things. Like we have to make first. We have to like find these things. Then we have to like
use both to find these things. First, we only used these to find the new values. Now he's saying use this also, but also use this.
Okay.
But we need only one, so we'll add both. Divide by 2. This is the like final one value, and just use this one value.
0 divided by 2 equals to 0.
Yeah, 0.
Okay.
So like 0, 10, 2, 5, 4, 0, 4.
This is the final
So
answer.
this, not the final answer. Use this here to find these.
Okay.
Like this.
Like is the B1.
B part.
Okay.
Till here we had A part.
Okay.
This is B part.
Okay. Till here you say
A part.
okay. Then okay, we got it.
These are just these calculations, these things.
Okay. And the B part.
This is the B part. We found this. This is given. Add both. Divide by 2. Now instead of using this, which we calculated, use this thing.
Okay.
And find the final weights and bias.
Okay.
That's it.
Yes, I'm one thing confused. Like they gave the first value. This one the values. So like we did nothing here for the B part.
No.
Okay. But at first we have to like put the value.
This is for A part.
Yeah.
Which we calculated. This is the B part, next part.
Okay. For the B part we didn't have to put the value here.
No. He's saying use this also, but use this also.
Okay.
Because we have found those values. He's saying use both.
Okay.
If he said
so
just use this.
Updated the weights and biases. If you use the both points, the mean square loss function in the first training iteration instead of the only using x1 is okay. So that is the final thing. And n equals to 0.1. It will be like the same.
In first part, we just used these values which we found. Now he's saying ये तो का use करनी है.
Yeah.
But also use these values.
Yeah.
Which I am giving to you. So add both, divide by 2, then again we get this one value, and then again this whole step to find the final weights and bias.
So again I have to do this step as well. Okay. So I just merge the steps, like then divided by 2, then I have to do this, then it's
again.
done. Okay. That made me confused at first. Like I don't think that I don't have to do it. But when you told me like after having this value, then I have to do this. Like I have to change only these values, last values, and put those values, and that will be the answer. Thank you so much.
No, it's okay.
Let's have a juice, please.
Okay.
The pomegranate.
Okay.
Like you want it hot or cold?
Hot?
Yeah.
No,
I love
cold.
it hot. Like you can like चाय पी ले
अच्छा चाय की तरह.
जिसके feelings आते हैं like like there was a party going on in our university, the Winterfest. They used to give like the hot drinks. Just keep it in the oven for like 30 seconds or 1 minute, and after that it's just literally awesome. The taste changed.
Okay, let's try.
Okay, just have a try. Just finish it.